Okay, let's try to fix our program so that we don't get these red messages. There's a couple of ways we can do this. First of all, I'm going to close the shell, get my program back up. And it really happens here at this line because we can't do a square root of 0. There is nothing. Or we can't do, sorry, not a square root of 0, but a negative square root. There's no such thing as a negative square root. So what I really need to do is build in some robustness with it, and I can ask the computer to try to do the equation, okay, and indent this part. And if it crashes, I can write what we call an exception, and I'm going to say that x1 equals no root. So I've given it a message of no root. So I'll fix the top one. I need to fix the bottom one now, the x2. We're going to do exactly the same thing. Try to do the equation. We know it's going to crash, so I'm going to indent that. And if it does crash, an exception, I'm going to say that x2 equals no root. Now the only thing that I've got to worry about here is that if I'm printing something out, that it's going to print a string or it's going to print a number. Because I've used the formatting technique here, that really doesn't care what these are, whether they're strings or integers. It's just going to use this as a placeholder and replace it. If I'd have used sort of concatenation with pluses, then again I would probably get an error at this point in my program. So that's the reason why I use format. So it doesn't really matter whether I've got a string or whether I've got a number coming to this point. So if I save my program now, I can run those two equations that gave me no roots. And the first one was x squared plus 1, so x squared, no x, and a 1, so I should have no roots. And there we go. The program does not crash, and it just tells me I've got no root for x1, no root for x2. Let's do it for the second one, where I had a minus x squared, no x's, and a minus 1. And we get no root, no root. Perfect. Let's just check that the rest of the program hasn't been affected by it. So let's just do an x squared. Yeah, both roots are 0. Let's just do a minus x squared. There we go, both are 0. And let's just do the other two just to make sure. So that was x squared, no x's, and minus 1. And then we get a root at 1 and a root at minus 1. Brilliant. And the other one where we're using minus x squared, no x's, and a value of 1. And again we get the two roots. So we seem to have solved our problem. So we either get no root or we get the two values of roots. And at the moment that is fine. I'm going to leave it in your hands to see what happens when you sort of use different values. So for example, if we're going to do x squared plus x minus 1, that we get, which is a quadratic, and we get two roots. I'll try that out now, but let's have a look at the graph for that. There you go, we've definitely got two roots, but the roots are getting a little bit more complicated. In fact, they're decimals. So yeah, minus 0.61 and minus 0.004. We'll try that one out and see what happens. It should work. Hopefully our program should be good enough to do that. So let's put that in. So what did we have? We had 1x squared plus 1x and minus 1. And there you go. We've got our two roots, and our two roots are at minus 0.61. Let's just get this off the screen for a minute. Minus 0.61. Yeah, that's pretty much where it is. and the x2 was at 0.618. So there, 0.615, pretty close, whatever it is. So it's working nicely. You need to check it out for different things. It might be nice if you do that, because then you'll see what happens when we put x's in and increase the size of this x, and you'll see what happens with the graph. It's always well worth analysing these quadratics, but you've built a program now that will give you the answer to any quadratic equation that you put in. One thing that I'm just going to finish off with, it would be nice if instead of asking for A, B and C here, is if we could just ask for the quadratic equation. They put the equation in, and actually that is probably the hardest program to write, because there are so many different ways to write a quadratic. Your program would be immensely complicated, immensely difficult, and I think if you check online for how do I enter a quadratic equation, most people will say, why do you want to do that? Just use A, B and C. So that will probably be Stack Overflow or something like that. How do I enter a quadratic? I can better still use some correct terminology. How do I pass a quadratic string? It gets kind of complicated, and you'll probably see from a lot of these that even if you copy these and check them out, a lot of them won't work properly at all. It doesn't give me what I was looking for, so let's go and take a look at the Java one. Yeah, again we're looking at just using A, B's and C's down here, so it doesn't like or it's trying to direct you away from actually entering in quadratics. It gets really complicated. So I was hoping for one or two snidey responses saying, why don't you just use A, B and C? But I can't find any. So there we go. Anyway, just ignore what I've said. That's our program. What we can do from here is move on to another program which will give us a quadratic equation in the form something like this, so that we factorize it: x plus 1, x minus 1. Whoops, that's not an x in there. X plus 1, x minus 1. And as you can see, that is also a quadratic equation, and that is one of the quadratic equations that we have played with. So it would be nice if we got our answers out and learn how to also give it in a factorized way. But that's for another video.